Hey, hi everyone. So in this video we will solve this problem to rotate the list. So we're given a linked list and we need to rotate the list by k places. So for example, in this case we have k equals 2. We take the the rotation of one rotation will take 5 to the head and 1 2 3 4 to the next, right? So let me just show you what does it mean. So I have list 1 2 3 4 and 5, right? In step 1 my linked list will become 5 and then rest of all numbers will come, right? In my step 2 my linked list will be 4 5, right? I took this element, brought it here, and like if I rotate, like I got the 4 on the head and then everything else copies, right? So let's go another step 3, right? In step 3 I will bring 3 to the head and everything else will follow. So okay, so guys, did you see the pattern? So for example, if my linked list is of size 5 and I need to rotate it by 3, I will pick the first 3 elements, right? Bring them on the head, point the last node's head, the last node's next to the head of the previous list, and point the next of the remaining one to none, right? So we can solve this by this pattern, that basically when we are given a size k, we just will see how many times we have to rotate the list. For example, if I have to rotate this list by 5, so my linked list, okay, let's do this. If I have to rotate this list by 4 steps, my linked list will be 2, and I just copy everything, right? And in my step 5 I will bring 1 to the head and 5 here, right? So what I need to do is, okay, I just need to see how many rotations I have to do and just do that rotation. So basically if there are a number of rotations I need to do is in the scale of is the multiple of the length of linked list, I don't have to do any rotation, right? And during the rotation also I just need to pick the, if I have to rotate any list by k elements, I just need to pick the last k elements, right? So guys, did you notice the pattern? We need to pick the last k elements. It's similar to the identification of the previous node of the kth element, the problem we solved to remove the nth node from the last. So I'll request you to go and watch that video first before jumping onto this video. I'll put the video link in the description below. So what we need to do is we need to have the access to this node so that we can fix, we can call it as a head and remove its next here, right? So let's dive deep to understand what exactly it means. So let's see the mission statement first, right? So let's say I have this linked list of some n number of nodes, right? And I need to rotate this linked list by k elements. So what I need to do is I need to pick this k elements, right? These elements, k elements I need, and this will be my new head, right? But if I need to make this an head, I need to remove the pointer pointing to the head, right? Which means I need the access to k plus 1th node. So if I need to have the k plus 1th node, right, what I can do is I will use two pointer approach to reach here. But how can I reach here? I need to make sure my fast pointer points at the end, right? If my fast pointer points at the end, so that I need to change its next to the head. So these are the steps. Let's go step by step. So what I need to do is, if I have access to the k plus 1th node from the end, and my fast pointer which will be at the last of the end, I can point this last nodes next to the earlier head, so that my linked list will become k to 1 and all other elements from head to k plus 1, right? And now I need to access this elements next so that I can make it next to none, right? And because it next was already pointing to k, I can call it as a new head. I need to access that. So guys, the pattern is very easy. We need to take our fast pointer k steps ahead of slow, because you see we need to access this last pointer and this k plus 1th pointer, and after k jumps I can reach here. So but the difference between two pointers will be k nodes, And because there is no need to have any guard or anything, because the k will be always less than the length. Otherwise, if it's in the terms of length, I will try to reduce it so that the we don't have to circle back to the number of rotations in terms of the length. So let's quickly jump to the coding part, and maybe then things will get clear. So what we need to do is, if my head is not there, I return my head, right? Otherwise, I need to see whether I need to rotate this list or not. So let's count the number of nodes. Let's call it 0, while this is iterator pattern, guys, to count the number of nodes, and I return the count, right? And now let's see the value of k. So my value of k will be k times mod of self dot count nodes head, let's call it, right? So basically I need to see how many additional nodes I have in comparison to the length of the linked list. So for example, if I have my k was 5, right, my k will become, then my new k will become 0. So in that case I don't have to do any rotation. So if my k was 6, my k will become 1, which means I have to rotate it by 1. So what I can do is, I can say, okay, if my k is 0, then I don't need to do any rotation, I return the head. Otherwise, for example, if my k was 1, right, if my k was 1, I need to have pointer to this node and pointer to this node, which means one step ahead of the node. If my k was 2, I need to have the pointer to this node and the pointer to the last node. So my k was 2 steps ahead, so that because I have to make this pointers next to null and have to have this as a new head, right? So let's do that. So let's call my slow pointer as head, my fast pointer as head, right? For I in range k, which means I have to do k jumps, my fast will be fast dot next, right? Until the time my fast next is there, which means I didn't reach at this node, right? I need to keep moving. I will say fast is fast dot next and slow is slow dot next. This is very easy, guys. I think I'll share few bunch of videos to explain the slow and fast pointer approaches, how to stay ahead of one node with various constraints that we want to achieve. So now here's the deal. If I had to do k is equals to 1, or let's talk about k equal to 2, I will be here. So this will be my place of slow pointer and my fast pointer is here. So what we can do is, we can point this fast next to my head. Here we said, right, this is my fast, and fast next I point to head, so that my linked list will become here to here, right? Let's do this. So what I say is, my fast dot next element will be head. This is step 1. Next is, I need to have access to my head node. So basically I am at this position, right? I need to know my next position, and I need to make its next none. So let's have this new head access. So new head will come with slow dot next, and I need to make slow dot next is equals to new head, sorry, none, right? So and then I return new head. Okay, let's try to submit this, guys. Okay, let's see. Awesome, it does. So guys, once again, I'll try to explain what I did. So I just counted the total number of nodes, and if I check whether I need to do any rotation or not. If I have to, then I take the fast pointer k steps ahead of me, and till the time I don't reach at the last node, I keep pointing them, so that at the end I have k steps of difference. And what I do is, then I just do 3 pointer changes. One is, I point my last nodes next to my head, and my new head will become slow dot next, which is like knowing where should I return my new list from, and I just end the list from the slow. I hope, guys, this makes sense. So if you like this video, please hit the like button and subscribe to this channel for more videos. Thanks.